Hello, everyone. Hope you're having an awesome time at AI4. This next session will be led by Patrick Wagstrom, Director of Emerging Technology at Verizon. Please join me in welcoming Patrick to our virtual stage.
Thank you. Welcome, folks. And hi, my name is Patrick Wagstrom, and I am a Director of Emerging Technology at Verizon. And in my role at Verizon, I work across all of our internal technology teams to help bring a wide variety of new and emerging technologies to them. AI/ML is just one of those. Some other ones that we work with our teams are IoT, blockchain, AR/VR, quantum, and a little bit with drones every now and then. But I'm going to focus on AI/ML here because I think that's all what you really are interested in hearing about. So let's start off, and they always say to tell the people what they're going to hear, tell them what they're going to hear, and then tell them what they just heard again. So here's what I'm going to be talking about is I'm going to be talking about four main concepts that you want to keep in mind as you're really trying to think about supercharging your AI/ML. Loving your data, being boring with process is actually a good thing, taking some lessons from software engineering, and then calling me if anything actually goes wrong. So we're going to walk through those, but first I'm going to set us up a little bit to talk about why do you need any of this in the first place? Well, as most of you probably know, AI/ML is not exactly an easy spot to be. We've known for a long time that a lot of our machine learning, that a lot of our IT projects fail, upwards of 70% of IT projects with some analysis. But now we're seeing that upwards of 85% of AI projects might fail. We're kind of in danger of getting a bad rap from all this, aren't we? And so, this is a case where I'm not here to say there's some magic bullet or something, but I'm here to set expectations. And that expectation is that this isn't going to be an easy process. The companies that have been able to do this well have spent a lot of time working on it. They've really tried to figure it out. And there's been a lot of companies that have tried to do this and they've failed. You will face challenges as you're working on this. And so I want to encourage some perseverance. It does take time, it does take patience, but eventually when you break through to the other side, especially when you're in a large enterprise and there's all sorts of other things that are going on that you need to be concerned about, you will be able to reap some of those benefits. So I'm going to start off and I'm going to talk about something that's a little like Maslow's hierarchy of needs. And I'm not the first person to try to map data science to Maslow's hierarchy of needs. But before we even get to the fun data science part that our machine learning engineers love to play with, we really need to start at some other aspects. We need to start at the business problems. And I'm going to talk just a brief little bit about business problems because those are really much domain specific. Those are specific to your actual enterprise. Then we're going to go into some of the issues, and most of the things that we're going to talk about lie in this data training, validation, deployment, and monitoring phase. Now, one of the interesting things about this is that as I was thinking about how this works out and what you're actually doing here, when you think about what AI/ML actually gets sold as, and how people that are coming out of master's and PhD programs might feel like it is, or how people that have done a lot of Kaggle stuff, there's this other level that goes beyond there. And that's when you finally are able to get all this. And, in Maslow's hierarchy of needs, they call it self-actualization. But when it comes to data science, once you have all this, that's when you're finally able to do some of the stuff about reinforcement learning, automatic hyperparameter optimization, adversarial networks, and all that stuff. So this helps us get there. This isn't going to say, all right, you need to start deploying GANs right away. This is one of the things that will help you get to have a maturity that you can use to actually get there. And hopefully that'll help make it easier for you guys to attract talent. We all know that talent is difficult, and also to retain that talent. So first, a little bit about business problems, because I think that it's important to actually start off with the problems that people are trying to solve. And that is, not every problem that you as a data science or an AI/ML leader are going to have come to you is actually fit for AI/ML. You do need to be picky about this because once in a while somebody will ask you to do a problem that just doesn't make a whole lot of sense. And really you need to be honest and say, all right, fundamentally what most problems are trying to do is they're trying to fit a curve. And there was a very popular discussion a couple of months ago. It is AI really just fancy curve fitting? And to some extent it is in just a high dimensional space. But most of them are really just classification or regression. They're either trying to say how far is something from a line or on what side of a line something is on it. And the more complex the problem, the more data that you need. And the more data and the more complex of the system that you have, the more questions that you need to ask. So as part of the intake process, before we even want to say, all right, what do I have to do in order to build out the architecture that we need in order to drive this stuff? There are questions that you should ask around how will this model be run? Will it be attended by a human being? What's the penalty for error? Those are the sorts of business questions that you need to ask the people about how it's going to fit into that deployment. And these are going to be very specific to your industry and your company, but they're things that I encourage you to ask. So let's start off with that next layer of the pyramid, and that is learning to love your data. In fact, I would say you almost have to Marie Kondo your data. You have to honor your data. You have to think about how your data brings you joy. And in some cases, that means if your data doesn't bring you joy, you should ask yourself, why do I really actually have this data? So this is a way of describing data that was taken from a nice book that came out last year called Data Architecture, a primer for the data scientist. And let's start off with all the data that you have in your enterprise. Most people on this call, they probably have terabytes. A handful of folks might have petabytes. And then a very few folks might be like what Verizon does, and we have exabytes of data. So we can think about the complete universe of the data that we have. And we can break that down and we can say, well, there's two different parts of that data. We have structured data and we have all the other data that goes along with it. On the structured data side, these are things like your current data warehouses, your OLTP databases. These are also things like Splunk or Datadog or something like that. But these are ones where you can go and you can write an SQL query against it. You can attach a BI dashboard against it or something similar. So this is ones where you've already got your data in good shape here. In most companies, this is actually only a fraction of the overall data that you actually have. So you still have all this other data. So what's the other data? Well, a lot of it is going to be repetitive data. A lot of times you will set up things that try to track elements. And let's say like you pull down your router configuration from every router in your network once every 5 or 10 minutes to detect any unauthorized changes. Well, for the most part, that data is going to be very, very repetitive because there is very little signal in there because the events when they do happen are extremely rare. So you have to look at it and say, okay, if this is repetitive data, ask yourself, is that data that I really need to keep around? So this is data that probably is not going to be super duper valuable for you as you're going through here. But you still have a bunch of non-repetitive data. And the non-repetitive data, you can kind of break up into textual data and non-textual data. So textual data is emails, transcripts, that sort of stuff. Might be annual reports if you're in the finance industry, everything like that, chat logs. Non-textual data is one that we're increasingly finding more ways to make use of. Video, audio, photography are probably some of the most common ones that people actually make use of there. And so just being aware that you have all this and saying, okay, well, how do I go from a world where before we were only building models with structured data to making use of textual data and non-textual data, especially when that needs to be highly customized. So one of the things that happens is that now that you know that you have this data, well, I was talking earlier about how data scientists, a lot of times they want to build models, but they actually don't spend a lot of their time doing that. Our data scientists actually spend a lot of the time munging their data. And so like, where your data is, well, how do you actually get it so that way, you're not spending almost 80% of your time munging your data and almost 80% of your time just managing it. That's an awful lot of money to be paying to these top tier data scientists and machine learning engineers for things where they're not actually doing stuff that's adding a lot of value there. Well, one of the big things that you can do in order to assist that is now that you know the types of data is to actually put in automated steps inside of your data lake process. And this is something where I've seen a lot of enterprises where like, oh, well, we're just going to have some checks and each team can actually run those checks. One of the best practices that we've seen both at my current employer and then at some of my previous employers too, is that if you actually build automated checks that go from your raw data lake into a curated data lake. So that way you know that, okay, well, if I'm going to be doing bulk analytics, I can use the curated data lake. I can go and I can pull out the data quality checks that were inside of a GitHub repository, and I can see what the data quality checks were. So I have an idea of what that is, and that information is written down. So that way there's no questioning about what it is. Furthermore, that information and those data quality checks are always run. You can't get to the curated data lake without it. And it's set up in such a way that you don't actually have to run it yourself. As a data producer, you don't have to run it. They're just part of the overall environment. That makes it much easier for me to publish my data and much easier for other people to consume it. Similarly, when you go from the curated data lake over to your data warehouse, a lot of those also have automated loading and automated checks that they can apply there before loading it in. That's another step. So that way it makes it easier for people to consume the data, but also easier for you to produce it. Because one of the things that often happens, at least when companies are very early in this process, is that having somebody use your data can actually be a bit of a liability. Because now they're saying, oh, well, I want to use your data, but you have to keep on producing it in this way for me. So I'd encourage you to think about how can I put in some automated steps, and I would encourage starting with a curation step and an automated loading step, so that way, and having those checks committed to a repository somewhere, so that way people can see what all those checks are and get an idea about the quality of the data. Next up, let's talk about being boring. On April 18th, 1930, the BBC came over the radio for their evening news program, and they said, nothing happened today. It was really weird. Well, of course, stuff happened in 1930. People were born, people died. But on that particular day, they said nothing happened because it was basically routine. And routine can be good. When everything is running routinely, that means that stuff is running the way that it is supposed to be. When you have a routine, you're able to catch surprises. If you keep on feeding the same data to the same model and getting the same result, that's good. That means that your model is idempotent, right? But now if you feed it in one time and you feed it to your model and your model gives you a different result, you're like, huh, what happened there? Having that routine helps you understand that. If you keep on training your model and it gives you the same results over and over again with the same training data, that's good. But if one time it gives you something different, then you have to look at like what actually happened. Maybe there was something weird like XGBoost isn't thread safe or something like that, which is actually something that can come up from time to time. So having these process actually allows you to catch some of these bugs that otherwise would be really hard to get at. And the process isn't just in sort of scripting everything out, although that's really critical. The process is about the entire life cycle. So this starts off with, okay, have we identified a business owner? Have we talked to that business owner to understand the risks? Have we identified the data owners of the upstream data? And so you really want to start to design a process that takes you from the left-hand side to the right-hand side. And I want to caution the teams that when you're designing this, to only design it for 80%. There's always going to be 20% of stuff or 30% of stuff where it's just not going to work. And it's really tempting to say, all right, this system, this is like some fancy real-time, real-time learning system that has a multi-arm bandit in front of it and everything like that. And, it's going to be absolutely amazing reinforcement learning and everything like that. There's probably something about that that's going to make it so that way it's harder to fit into a standard process. So I'd say start off with with stuff that's more routine, and then figure out the spots where you can take the process for some of those more complicated systems. And you might be saying, like I used to say, well, hey, I've been doing this stuff for 20 plus years. And, I know how to build a model, like it's fine. And, that's probably true. You probably do know how to build a model, but sometimes you still forget stuff. And that's why there's plenty of research about how checklists actually improve what you're going to be doing. So I'd encourage you to start to list a set of questions that get asked of every time that you build a model. And your enterprise will want to decide on this for themselves according to their level of risk and the industry that they're working in. Some industries have more well-established guidelines than others that you'll want to be aware of. But now that you've got that process, I really want to encourage everyone to make sure that process and those steps are documented, and that they're clearly documented. And for a model, those can be documented into something like a model card. So this is research that came out of Google and was published at the ACM Fat Star conference in 2019. And the Fat Star conference has now been renamed FACT, and it's happening virtually in March if people want to go to it. But this is the ACM conference on fairness, accountability, and transparency. And so this is a model card that Google published in relationship to some of the segmentation algorithms they just introduced in Google Meet. And you can see, if you were to look at it, the type of model, it covers the things about the inputs, the dimensionality of the inputs, who built it, what the licensing is. And then as you flip through this, it talks about other elements around the risks of the model and how the model was trained and everything like that. And so this is great because it gives you something where all that information is documented. In other industries, like in finance, a lot of times you need to have a complete model white paper that talks about these things. But you don't have to go and say, all right, if I'm just starting on this road, I don't have people that know how to write model cards. I don't have people that are going to know how to start a model white paper. Really, what you can start off with is just saying, all right, I've probably already got an issue tracker for this. I've got a GitHub repo, or I've got a Jira board or something like that has all of my issues related to this project on it. Just create a single work item for every single issue that you're talking about. So do you have a business owner? Has that business owner signed off on the risk? Have you made it clear about how you're going to monitor the model? Do you have a pipeline in order to build the model? All of those are things that you should actually have in there, just so that way you know that you've addressed it, and make it so that way there are requirements to have closed off before you actually ship the model to production. And so I've seen teams where actually they go through, and as soon as you create a model repository, they just go and they populate it with these 20 or 30 questions that they have. It's a great way to start off and to get people to really think about what are the questions that they need to be asking as they're building the model. So I alluded to pipelines there. And so I want to talk a little bit about that. And so I actually started off more on the software engineering side than on the data science side. I was using applied data science before data science was a word in order to understand how software engineers in the open source world build software. And there's a lot of great things that have come out of open source. And one of the things that has come out of open source is, of course, most of our data science tools. And so this is a Jupyter notebook, and I just grabbed a simple GPT-2 notebook. So it doesn't matter what really this is, but what I'm using it to show is, like, notebooks are complicated. We use them to train our models, to share information about our models, to share like, how did we make this decision or that decision. And so I had an experience when I started off at a previous job, and I inherited a team that was building a model. I said to the data scientist who built the model, I said, so how do you actually train that model? And so the data scientist opened their laptop and they brought up two different notebooks side by side. And they said, all right, well, I think that I start in the middle on like line 5 here. And if I run this line and then I jump down like 3 more lines, and then if I go to this other notebook and I run everything from top to bottom over here, and then if I go back to the first notebook and run everything from top to bottom, then I get a pickle file that I email to somebody, and that's what actually gets shipped to production. And so within that, there's a lot of tacit knowledge that's kind of encoded in there. And that's the sort of thing where you have to take a step back and say, boy, that is a big problem if that data scientist decides to leave our company. That's also a big problem in terms like our overall maturity in understanding where bugs are. Because it's like, why do we need to run some of these lines twice? Do we actually need to do that? Have we thought about how this is actually going to be maintained? And so that's where really one of the things that I am excited about is that we're seeing more and more pipeline frameworks that are coming out. So for your models, as you're building them, you really should be thinking about what are the pipelines that I'm going to be using in order to do this. And so this also helps out with, you can think about building out a model white paper or a model card, because you can say something like, I'm going to have the pipeline automatically calculate elements around the hyperparameters and everything like that. And I'm going to have it automatically run it against this test set and this training set, and actually give me some of those numbers automatically. And so, obviously there are things like Airflow, Kubeflow, TFX, Prefect, and lots more. If your data scientists aren't using these as part of their process, and if you're using Spark, you kind of get some of the stuff through the whole way that you write a Spark job and everything. But if your data scientists aren't using some of these, I would highly encourage that you start doing that, and that you start saying, all right, even if it's as simple as just 3 lines inside of a kube and inside of an Airflow DAG that say what's going on, it is a start. And so, like, let's not have this be everything needs to have an Airflow DAG with everything in it to start off with, but eventually you can get there, because eventually when you start thinking like this as an Airflow DAG or a Kubeflow DAG, there are components that you can generalize. And so suddenly you can say, all right, I want to have a general component for taking a trained model and uploading it to an Artifactory repository. And when you're thinking like that, then you're like, okay, well, now I have a component, and that component can be maintained by a really high quality team. And then we don't have to worry about other teams doing things their own way. We can ensure that every one of our models actually gets in there. One of the things that I want to stress here is that these actually should be checked into version control, just like everything else should be checked into version control as you're working on it. So your model pipelines, put them in the same repository. And then one of the nice things about that is that even if it's not the case where your final build is always triggered with it, you could say, all right, I want to have it so that way whenever somebody on my team makes a commit, then they create a pull request. That pull request eventually gets merged into the Git repository. When a pull request is merged in the Git repo, then Jenkins sees that, and then Jenkins fires off an Airflow DAG, and then the Airflow DAG produces a pickle or Mojo, an Onyx object or something like that. And so, like, that's a very nice way that you can start to think about, how do I make it so that way this happens all the time behind the scenes? Because now you can say, all right, well, I just trained a version of this model. I'm going to do a PR on it, and because maybe it wasn't committed yet or anything like that. And you can say, all right, well, now I've got another version that's trained. I can validate that against the two. I can make sure that my environments were consistent. I can make sure that if we ever need to rebuild this, I'm able to do this over and over and over again without any major sources of derision. And that's a really critical step. So I'd encourage you guys, even if you're building a system where it still is like manually submitting a job to a job queue or something like that, that I would still consider having your pipelines trigger a model build, because it's another way that you can remove some of the inconsistencies that might actually go in there. And that's kind of a theme. Like you kind of heard me talk about automation earlier. Automation really is like the big thing that will help you supercharge everything. And then the last thing that I want to talk about is what to do when stuff does go wrong, right? Because we know that stuff is eventually going to go wrong. Like it wouldn't be software, it wouldn't be a model if things always worked right all the time, I feel like. And those of us that have been around for a while have had models that, for one reason or another have gone absolutely crazy at some point. And so the first thing is most people are now deploying their models as some form of a Docker container, or at least a lot of people are. And those models get deployed, and they're exposed via a REST interface. And you can use systems like Algorithmia to do it, or Domino makes it really easy to do this. Selden also makes it fairly easy to do this. So you can go through and you can make a model, wrap it with a small REST or a gRPC interface, and put it out there. And then you don't have to worry about scaling it up with load or anything like that. You don't have to worry about keeping it running. That's one of the things that a lot of these environments do. And in that sense, a model is still a software artifact, right? So it is still something that is out there that, you want to have those logs be sent to your enterprise logging store. So you want to have those textual logs be sent there. You want to have your metrics. So if like such as what you grab with Prometheus, so your CPU load, all that stuff, your memory, all that stuff, that still should go to your enterprise metrics store. And if you're doing tracing, or if you feel the need to turn on tracing because you likely don't have it on all the time, that should go to your enterprise tracing store too. So in that sense, when you start off, it's like, yeah, it is a lot like it. You have a client that's going to invoke a REST interface on your model, and it's going to do some stuff, and it's just like everything else, just like a CRUD operation in some ways. It's just that it's creating a score. Well, but there's also some other elements here, because it's not as clear cut about exactly what's going to be happening. So they also need to be monitored a bit differently. And so one of the things that comes across as you're thinking about your process is making a note of what you're going to monitor when it's in production, beyond just the typical sort of software stuff. And that means thinking about how you're going to be monitoring your feature input and your scoring output. What sort of things you're going to be looking for the shapes of those, for the shapes of that data. And this is where, once you actually have a lot of a data catalog or something, you can start to look at what other people have done to monitor it too, and add it in there. And we're seeing an increasing number of startups in this area, and well-established companies that are driving solutions in here that are doing some really amazing things. So Arthur is a very interesting company that has a great SDK that you can use in order to monitor your inputs and your outputs. Domino has their model management capability that's part of this too. And so you can define like a mathematical threshold where if you start rejecting more than half of your customers' applications or something like that, or if it's up 10% from what it was yesterday, then you start to trigger something. And you define those upfronts. That way, when things go wrong before they actually go wrong. And that's the critical thing. And because then it becomes sort of a checkpoint of saying, I think these are the things that I'm going to need. Before we can say everything is done, they must be checked out. But this is actually where things get really, really nice. Because if you think about it, then, okay, well, if I'm just monitoring the input output, there's some fun things that I can do, because this shouldn't have any side effects. So when you have an architecture like this, one of the things that you also should be thinking about is you can easily deploy multiple versions to production, right? And so like this is where things get absolutely fun and fascinating. Just thinking about having 10 versions of a web front end deployed to production, well, that's kind of difficult, because it's not like you're going to be showing the same person 10 different web pages. But a machine learning model, if it's just scoring in the background, you can set up shadow scoring like this. And so you can have it where you have the same feature input go to 10 different versions of the model, or 100 different versions of the model, or 1,000 different versions of the model, in order to see, yeah, I know I had my data that I back tested this on, but how is it really working in production, if you want to be absolutely certain about how it's going to work ahead of time. And so this is a really powerful thing. And that also helps to open you up to new sort of model deployment architectures that a lot of those platforms that I mentioned earlier, such as Selden, give you, whether it's multi-arm bandit or a rendezvous architecture or something like that. It opens that up to you. And so that's what I wanted to say, like the monitoring is probably like one of the key things, because once you do that, you can start experimenting with those model architectures, right? You can start scaling all those up and doing all sorts of crazy things with it, because now you've got the ability to deploy them in shadow scoring mode and monitor the output against real production data without having to worry about interfering with their production pipelines. So what did you guys just hear about, and what did I just talk about? I wanted to remind you guys, the 4 steps that I believe are really critical in order to supercharge your AI/ML. One is loving your data. really getting a grasp on that and automating your data-centric environment wherever possible. And that's because data scientists spend a lot of time munging that data. So there are two critical spots where you can automate it are to going into the curated data lake and going into the data warehouse. That's a great spot to start it. Two, boring is good. Develop a checklist, drive towards something like a model card or a model white paper culture inside of your organization. It really, really helps out in terms of consistency and in terms of also letting your data scientists migrate between projects. Three, use pipelines for model training wherever possible. And four, define your model monitoring solutions and monitor the data and the output as you're going along, in addition to the software attributes. So once again, my name is Patrick Wagstrom. I am a director of emerging technology at Verizon, and I wanted to thank you guys for spending a little bit of this afternoon with me. Thank you.
Awesome job, Patrick. A big virtual round of applause from our audience. Yay! All right, if you're looking for your next session, you can go ahead and check out the agenda page and then take some time to connect one-on-one with your peers in our networking room. Thanks, and keep enjoying AI4.